Hey, yo, 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 yo. Thanks for joining. Got the video on area of composite figures here. So, first key term we need to know is composite figure. And a composite figure is a figure made up of simple geometric shapes. So, if I have, let's say, like a house, the shape of a house, this would be a composite figure. It is made up of a square or a rectangle and a triangle. But we just don't have that line here because it's a different shape, but it's really made up of two simple geometric shapes. So that would be an example of a composite figure. So first thing that we need to know is we need to know the formulas or how to find the areas of these simple shapes if they were not composite figures. We need to know just how to find the area of a triangle, a square, a rectangle, a parallelogram, and a trapezoid. Once we know all of how to find the area of all of those, we use those formulas to find the area of composite figure. Because what we do with composite figures is we split it up into simple shapes so that we can find the area of simple shapes. And then we just add them all together. So like going back to my initial house example, if I wanted to find the area of this, what I would do is I would say, okay, well, this is really a house, this is really a square, and a triangle. So I would find the area of the square. Let's say like this was 2 by 2. So the area of the square is 4. Let's call them centimeters, so I can call it square centimeters. And then I would want to find the area of this triangle. Okay. And then I would add that up. So going back to our examples at hand. So here I have all of my formulas. So triangle is equal to 1/2 times the base times the height. So really a triangle, you guys, is just taking a rectangle and dividing it by 2. So you can multiply by 1/2, or another way you can write this, and you guys might like this version more, is you take your base times your height and you just divide it all by 2. So that might be easier than multiplying by 1/2, easier way for you to look at it. I don't know. A square is just length times width, or the side multiplied by itself. Rectangle is length times width. Parallelogram. Parallelograms are the ones that look like this. Nice little reminder. Where all 4 sides are parallel. So parallelogram, if you need to draw a picture to show what it means by base times height. Whoa, that was a spaz attack. Sorry guys, hold on. Is when you take the base and you multiply it by the height, but the height is at a 90-degree angle. So parallelogram is very similar to a rectangle. It's just base times height or length times width, but we call it base times height. And then a trapezoid. Trapezoid is probably the most confusing looking formula. However, let me show you what it means. So here's a trapezoid. I guess I should probably draw it by where it says trapezoid instead of up at the top. So here's a trapezoid. Trapezoid has one set of parallel lines, and another set's not parallel lines. So a trapezoid, what's different about a trapezoid is that we have a base 1 and base 2. It does not matter which one I call base 1 and base 2, but what it's saying is the parallel lines of the shape are the 2 bases. And then you still have your height at a 90-degree angle here. So for a trapezoid, we have to add the bases together first here. That's just B1 plus B2. We're just calling it that 1 on the bottom is saying this is the first base, B2 means this is the second base. And then once we add them up, we multiply it by the height. And then we have to either multiply by 1/2 or we divide it by 2. Multiplying by 1/2 is the same thing as dividing it by 2. So again, you can rewrite it if this looks easier to you because it's the same thing. Height times B1 plus B2 all divided by 2. And again, we'll get practice and show you how to use these. So back to, now let's go and actually look at some composite figures. There are so many different ways, you guys, to work on these and figure these out. You can divide it into a bunch of small shapes. You might be able to use some bigger shapes. There's a lot of ways to do this. There really are. So on this first one right here, I'm going to look at this as a parallelogram. And I'll draw that parallelogram. So let me just focus on that parallelogram first, and then I'll work on this bottom piece. So this parallelogram right here is, let's see, I have a parallelogram to find the area, because what I did is I figured I have a parallelogram. This right here is actually a trapezoid, or I can do a triangle and a rectangle, but let's just focus on the parallelogram, because to find the area of this composite figure, I got to find the area of all the individual shapes. So I'm going to break it up into the shapes that I can see. And I see a parallelogram here with a height of 1.5 and a base of 10. Looking at the formula for parallelogram, it's base times height. So for this parallelogram, if I need to draw it off to the side, I can. That's totally acceptable. I know that this is 10. That means that this has to be 10. And I know that this is 1.5. So to find the area of a parallelogram, I got to just do base times height, which is 10 times 1.5, which is 15. So I'm going to write that in the middle of my shape. This is 15 centimeters squared, because I figured out the area of that piece. Now, let's look at this bottom. I could do the area of this as a trapezoid. This is a trapezoid. The reason why it has one set of parallel lines, 4 sides, with one set of parallel lines. I have base 1, I have base 2, and I have a height. Here's what I mean by that. And I'll redraw it so I can show you all the sides, because it can get a little confusing with all these different numbers. We know that this is 10, because this was 10 up here. And then I know the height is 1.5. So, area of a trapezoid, the height is 1.5. The bases are 10 and 7, so I add those up, and then I divide it all by 2. So then I always have to do my parentheses first. So this is 1.5 times 17, all of that divided by 2. Now, I need to actually multiply 1.5 times 17, if you guys don't mind here. I'm going to use a calculator just to make our lives easier. So 1.5 times 17, 25.5. So this is 25.5 divided by 2. So I can plug that back into my calculator. It's 25.5 divided by 2. 12.75. So what I figured out is that the area of this trapezoid is 12.75 centimeters squared. So I figured out the parallelogram, I figured out the trapezoid, so now I have to add those up. 15 and 12.75 make up this entire figure. So 15 plus 12.75 equals 27.75, and that's centimeters squared. Because whenever we find the area, we always call it square centimeters. And I am all done. So, quick summary. Composite figures. Okay, I'm going to erase all this stuff, so if you have to rewind it, you can. But this is a composite figure. It's a big shape. There's a lot of stuff going on here, so if you need to redraw it, redraw the shape separately to make your life easier so you can just focus on a single shape at a time. Break it down into shapes that you know what they are. So I broke it down into a parallelogram and a trapezoid. We could have also, there's a triangle here, right? So I could have done triangle with a rectangle with a parallelogram. That would have worked. And I'm doing these different colors to show you. So those are 3 shapes. I could have added them all up. I still would have gotten the same answer. So break it down into any combination of shapes that you would like. Now, extra practice here. So I have this composite figure. It looks like we got a square, and it looks like we have a half circle, or semicircle, so a half circle. So, let's see. I know that all the sides are 10. So, let's just figure out the area of the square first, because that's the easy one. 10 times 10 is 100. So right now I got 100 meters square for the square. Now I'm going to redraw this half circle or the semicircle over here. And I know this length right here is 10. So for the area of a semicircle, let's just find the area if it was a whole circle, but then divide it by 2 because it's only half of it. And luckily we're given the diameter here. So I know my formula for area of a circle is pi times the radius squared. I'm given the diameter, which means that half of the diameter is the radius, and therefore my radius is 5. So the area is pi times 5 squared, which is 5 squared is 5 times 5, which is 25 pi. So now I got to do 25 times 3.14 to get 78.5 for the area of the circle. But this is a semicircle. So I have to find the area first, and then I can divide it by 2 because it's only half of a full circle. I found the area of the full circle, so I got to divide it by 2. Notice how I didn't divide my radius by 2. You're not allowed to do that. Okay? We have to find the area of the entire circle, and then we have to divide by 2 at the very end. So if I just plug it and divide it by 2, I would have gotten 39.25. So going back, we had the square is 100, 39.25. If I add those up, I get 100. Whoop. I get 139.25 meters squared for this composite figure that I broke into a square and a semicircle. Go ahead and pause it. Try to find the area of this one over here. Looks like we got a rectangle and a triangle. See if we can figure it out. All right. So I got a rectangle and a triangle. Let's see if I can make this a little bit bigger for us. There we go. Zoinks. Nice. All right. So rectangle and triangle. My rectangle is 4. I'm going to write in all this by 10. So I like to see all the sides. 4 by 10 is just length times width. 4 times 10. That is 40 square feet. I'm going to write that on the inside. Now the triangle here. I have the base of the triangle is 6. So for area of a triangle, I'm going to redraw this triangle over here. Here's 6. I need the height of the triangle. Well, it says it's 3 from here to here. And I know since this part was 4, that this part's 4, to mean this whole entire side is 3 plus 4, which is 7. So there's the actual triangle that I'm trying to find the area of. Now, triangles are simple. It's just take the height, multiply it by the base, and then divide by 2 because it's really half of a rectangle. So, for area of a triangle, I'm going to do 7 times 6, but then I'm going to divide it by 2 in the end. 7 times 6 is 42. Divide by 2 would give me 21. So this triangle is 21 feet squared, or square feet. So I now have my areas. I have 40 feet, I have 21 feet. That makes a grand total of 61 square feet for this composite figure. And I am done. So that's it. We have no more. So a couple things. Things to remember. Things to remember. Let's see here. Break down into small, simple shapes. So when finding the area of a composite figure, we're going to break it down into small, simple shapes, add up all simple shapes, all areas of simple shapes. Sometimes you'll have 4 shapes, maybe 5. We just did 2 problems where we only had 2. But we've got to make sure we add them up in the end. That's super important. Okay? I'm trying to think if there's anything else. Let me just do a quick little recap. Formulas. We need these formulas. These are very, very important to know. It's very important to know what the base and the height are of a parallelogram, of a triangle, of a trapezoid. Super important. Okay? And that's it. So I hope this helped. And try out this independent practice here. And again, just got to start looking at it and maybe break it down into different shapes. And that'll help you out quite a bit. Okay? And if you guys have any questions, please do not hesitate to ask. Thank you for watching and tuning in. Cordias out.